In this video, we will see two-dimensional array. Whatever array it is, one-dimensional array or two-dimensional array or three-dimensional array or 4, 5, 10-dimensional array, the elements are going to be stored in a contiguous manner only. So let's say if this is your elements of array, which is a two-dimensional array, integer array. Okay. So just like in the last video, we have seen how to declare a one-dimensional array, which is data type A, and just one bracket was used because it is just one-dimensional array. And the number in that declaration, the number under the bracket represents the maximum number. So in case of one-dimensional, this is how we see a integer A and let's say n. This means that it is a one-dimensional array of n elements. Maximum elements it can take is n. Okay. So if you're with in case of arrays, we have a fixed size that you give beforehand. In this case, in a two-dimensional array, now you are giving two brackets, okay, and m and n. For each of the dimensions, you are giving the maximum numbers m and n for each of the dimensions. If it was three-dimensional arrays, then the declaration would be something like, we will see three-dimensional in the next video and dimensional in the next video. But just look at here. So data type, if it was A, then you will have three such brackets. Okay. And what is the total number of elements in case of one-dimensional array? Let's say int a n, the number of elements of the array is n. In case of two-dimensional arrays, like in this case, data type a m n, what is the total number of elements? The number of elements of array is going to be m into n. Okay, number of elements is equal to m into n. Okay, now let's look at here the array. The first element of the array starts from this location, and the last element is at this location. Total number of elements, as you can see, it is 12. So I am taking one declaration in a3 and 4. Okay, another possible declaration for this array could have been whatever you like, could have been int a2 6, but just the multiplication should give you 12. Int a 3 4 4 3. Okay, now that you know that this a is name of the array, so this a is name of the array, and a points to the is a pointer to the first element of the array. And in arrays, you can randomly access any element using indexing. For every element, there is an index, and by giving an index, you get the element. So in case of 1D array, A5 means you are accessing the sixth element of the array because the index starts from 0. This is in case of 1D array. Similarly, in case of a 2D array, in case of 2D arrays, how can you look at that array? You can access any element, but what about the indexing of in case of 2D arrays, how the elements are indexed? It's actually 2D arrays is you can look at 2D arrays as matrix, and the indexes. By the indexes, the matrices. The element. So if you want to access A11, means access element that is here, then A11 giving this will give you that element. Now actually the memory is organized in case of 2D arrays. How the memory is organized is in two ways. Either it is row major order or column major order. What does it mean? It means if it is row major order, actually, 1 minute, actually 2D arrays, you can think of it as a collection of 1D array. Similarly, 3D arrays, they are a collection of 2D arrays. So 2D array is a collection of 1D array. 2D arrays is a collection of 1D array. Okay. And what 1D arrays? So you can think of it in this, in case of row major order, if it is a row major order, if the memory is organized as a row major order, it means what? It means in your memory, how this, how the elements of this matrix is stored is, first row is stored, first row is stored, then second row is stored, then third row is stored, and so on. If row major order is being followed, it means that first row is stored, then second row is stored, then third row is stored. Means in one row, how many elements are there? 4 elements. So 1, 2, 3, 4. This is first row. Okay. Let me erase this. Here you can say in the upward I will use indexing for row major. So if row major order is followed, then this is your first row, because for each row you have here 4 columns, so every row has 4 elements. 4 columns means every row has 4 elements. So this is first row, this is second row, and this is third row. If your memory is organized as a column major order, then column major order means that first column is stored, then second column is stored, then third column is stored, then fourth column is stored. Okay. So for every column, how many elements are there? 3. Every column you have 3 elements. Okay. So number of elements in any column is equal to number of rows, and number of elements in any row is equal to number of column, right? So if column major order is followed, then it means first these 3 elements are first column. This is first column, this is second column, this is third column, and this is fourth column. Okay. And how the indexing will be then? So indexing will be, okay, this is first row, second row, third row. Okay. And what would be the index? The first index will be, if it is a row major order, so the indexing will be this is A00 element, this is A01, this is A02, first row A03, then second row A10, A11, A12, A13, A11, A12, A13, then A20, A21, A22, A23, A20, A21, A22, A23. This would be the index. Okay, so what is the index of 5? What is the index of this element? So index of this element in row major order is this, then this will give you 5. Okay. But if the column major order was followed, then what would be the indexing for each of these? Indexing would be first column is stored, so A00, A10, A20. Then okay, so now column is fixed as the second column because indexing starts from 0, so second column is 1. A11, A1, A21. Now third column. Okay, third column. Number of elements in third column is 3, and this will go from 0, 1, 2. Okay, A01 to A1 to A2. Now fourth column. Fourth column means the placeholder is 3. And A01, A0, A13, A23. So what is the matrix? If row major order is followed, then what is the matrix of this array? What is the 2D matrix in case of row major order? So in case of row major order, the matrix is 12, 11, 1, 2 as one row. 12, 11, 1, 2. Okay, 3, 4, 5, 6, 7, 8, 9, 10. And what is the matrix for column major? Column major order. In column major order, 12, 11 and 1 is first column. 12, 11, 1. Then 2, 3, 4 is second column. 2, 3, 4. 5, 6, 7 is third column. 5, 6, 7. And 8, 9, 10 is 8, 9, 10 is fourth column. So let's give a summary to this video again. So in case of 2D array, this is how we define a 2D array. Every bracket refers to one dimension. Okay, so it's x-axis. You can you can think of it as yes, of course. You know the concept of dimensions. Dimension x-axis, y-axis, z-axis. You can think of it like that. Even in linear algebra, you have seen something called as vectors, and vectors have dimensions. Okay, leave linear algebra. So this is how you declare, okay, a 2D array. Each of the bracket is one dimension. Okay, and in case of 2D array, we can call these dimensions the first bracket that comes as the row and the second bracket that comes as the column. And how the memory is organized, it may be organized either as row major or it may be organized as column major. Okay, the first bracket is for row and second bracket is for column. The first dimension is for, you can call it as row, the second dimension you can call it as column. And when you call them row or column, then how the memory is organized is either row major or column major. So actually a 2D array is what? A collection of 1D array. If it is row major order, then this is one array. This is one array. This is another array. This is another array. So this 2D array is a collection of 3 arrays. In this case, if a row major order is being followed, then 2D array is a collection of 3 1D array of size 4. Okay, 3 1D array of size 4. If the column measure order is being followed, then in this case a 2D array is a collection of 4 1D array of size 3. 4 1D array of size 3. Okay. Now in the next video, we will see 3-dimensional array.